Okay, so what this video is on is something called the empirical rule. The empirical rule has to do with something called a normal distribution, which usually has something to do with, we do a lot of testing and surveys and everything, and basically it's when you have a symmetric, single-peaked, bell-shaped curve, and your mean and median are located at the same place. So the empirical rule itself is that 68% of the data is located within one standard deviation of the mean. 95% of data is located within two standard deviations of the mean. And 99.7% of the data is located within three standard deviations of the mean. So those three numbers are important for you to memorize: 68, 95, 99.7. And sometimes it's even called the 68, 95, 99.7 rule. Here's what it would look like. You have a curve, say, representing test scores. Let's say where our mean, which we represent with this mu, is 100. And my standard deviation, sigma, looks kind of like a little zero with a tail on it, is 10. Then that means my mean is at the middle. And if I go plus one standard deviation to the right, that would be 110. If I go minus one standard deviation, that would be 90. So the empirical rule says that 68% of my values are going to be between 90 and 110. If I go one more standard deviation in each direction, that would be 120 and 80. All I did was add 10 and subtract 10, respectively. And my empirical rule says that 95% of my data will be between those two values, 80 and 120. And then last, if I go one more standard deviation, so 70 and 130, my empirical rule says that 99.7% will be between those two values. And so then we'll answer all sorts of questions. What percent is between 80 and 120? What percent is between 80 and 110? What percent is lower than 90 or higher than 120? When we answer questions like that, it's helpful to keep a couple things in mind. First of all, my graph is symmetric. So that means if I go down the middle, half of it, so 50%, is to the left, and half of it, the other 50%, is to the right. Now, these problems, there are so many different ways that you can think of this, so it really is just whatever makes sense. So if you see a different way to solve it, good for you. How I like to think of it is first I do my mean and standard deviations at the bottom. Then I label my 68, 95, 99.7, and then I basically split each of those in two. So the 68 is this chunk right here, right? If I split that in two, I would get a section that's 34 to the left and 34 to the right. My next section goes out to 95, but I've already accounted for 68. So if I did 95 minus 68, that gives me 27, and I need to split that 27 in two. So that means that this middle piece is going to be 13.5. The next middle piece is going to be 13.5. And if I added 13.5 plus 34 plus 34 plus 13.5, I should end up at 95. Then the next part counts for 99.7. So I need to do 99.7 minus what I have already, which was 95. So that's going to be 4.7, which means that this little tail part is going to be 2.35. And I don't sit here memorizing these decimals. I just learn them or rewrite them for each problem if I need it. And last, my 3 standard deviations doesn't cover everything. It covers everything but 0.3%, which would mean I would have 0.15 to the left, 0.15 to the right. And I know if I did it right, when both sides are symmetric, so I have 34, 34, 13.5, 13.5, 2.35, 2.35, 0.15, 0.15, and if I add them all up and I get to 100%, I am good to go. So let's look at what an actual problem might read. So in this one, we have an average of 100, hey, see that number again, and a standard deviation of 16. So like I said, the first thing I like to do is label. So my mean goes at the middle, 100, and then I'm going to just go straight through and add 16 going to the right. So that would give me 116, 132, 148. Whoa, that was ugly. Then I go back to 100 and I go subtracting. So 100 minus 16 would be 84. Minus another 16 would be 68. Minus another 16 would be 52. And then I think in the middle I have 68, so that's 34. 34. Then I go to 13.5. And then I go to 2.35. And on the end, 0.15. I would encourage you to write those out on each of these problems and you have a big normal curve, because it's really going to help and you'll learn the numbers a lot faster if you do it that way. Okay, so if I'm going between 68 and 132, so that's 68 to 132. Well, that's nice because that's 2 standard deviations. So what percentage are going to be between 2 standard deviations? Well, that's just going to be 95%. I don't even need to do any math. That's just my straight up empirical rule. The next question says less than an 84. So let me carefully erase that. Okay, so less than 84. So that means I need to look at everything to the left of 84, which would be 13.5 plus 2.35 plus 0.15, which will give me 16. I could also see it as everything to the left of 100 is 50, and I don't want between 84 and 100, which is 34, so I could think of it as 50 minus 34. I should get the same answer. Cool. Whichever way you see that is fine. Okay, and you're going to notice that a lot of these numbers will start showing up all the time. What percent of 12-year-olds have an IQ that is less than or equal to 84? Well, that's just going to be exactly the same thing I just said. So that is also going to be 16. What percent of 12-year-olds have an IQ greater than 148? Look, I've already labeled this on my diagram. Here's 148. I want the percentage that's to the right. That is only 0.15%. So, hardly anything. Next question says, what percent of 12-year-olds have an IQ greater than 68? So that's wanting everything to the right of 68. Now, once again, so many different ways that I can think of splitting this up. I